This topic is solving an exponential equation by using logarithms. Exact answers in logarithmic form. For this particular exercise, we'll have the x in the exponent in both sides. So we have something like 7 to the minus x plus 4, which equals 16 to the 3x. And the thing with these exercises is that x, we have it in the exponent here and in this exponent here. So we gotta find a way to take that x down. How are you gonna do that? Well, to accomplish that, we need to apply logarithms to both sides. There are two possible ways. We can apply natural logarithm to it or logarithm base 10. Any way works, and Alex will identify any as a correct answer. Let us do it with logarithm base 10 to see how we would solve this exercise. So first thing, we apply a logarithm on both sides. So I'm going to have logarithm of 7 to the minus x plus 4 equals logarithm of 16 to the 3x. And why would we want to add a logarithm to our equation? Because the purpose of this is to apply our power rule. Power rule of logarithms is the rule that tells me whenever I have the logarithm of a number, for example 5, to an exponent, for example 2, I can rewrite that as 2 times the logarithm of 5. Notice what happens here. What happens here is that I am taking this exponent down. I no longer have it here. I will have it down. And because I know this property, and I know that this way I can take an exponent to the lateral side, I want to apply it. So that's why I apply the logarithm to both sides, with the purpose of doing that later. Okay? First thing is writing the logarithm. Now that I have that in a logarithm form, I want to apply that rule. So I'm going to apply the power rule of logarithms, which is rule number 3, as we saw that in class. If I apply that rule, I'm gonna end up with minus x plus 4 multiplying logarithm of 7, and this is equal to 3x multiplying logarithm of 16. That is just because I applied this rule. I took the exponent down. This is power rule. Now I will multiply. I will do the distribution of this. Okay. That is going to be minus x logarithm of 7 plus 4 times the logarithm of 7, and that is equal to 3x logarithm of 16. In this case, I'm gonna continue here. In this case, what can I do then? I see that I have x written here and here. So what I want to do now is take all numbers which include x to one side. We can either move this to this side or move this to this side, and it doesn't matter, it's the same. I'm gonna take this to the left side. I do that by subtracting it. So here I have minus x logarithm of 7 plus 4 logarithm 7, and then I take this subtracting minus 3 times x logarithm of 16 equal to 0, because here I have a plus 0. Okay, all I did is take to the left side the terms that have x in it. Now I want to move to the right side the term that does not have an x in it, which in this case is only this one. So I'm going to move that term to the right side. It should look something like this. Minus x logarithm of 7 minus 3x logarithm of 16. This equals minus 4 logarithm of 7. All I did here was take this to the right side, subtracting because it was adding up. Now, I am closer to the answer, but I have the x here and I have the x here. Well, I can do a factorization. When I have a term repeated in all of the terms, I can factorize it. I will factorize x. That is multiplying minus log 7, and it's also multiplying minus 3 log 16, and that is equal to minus 4 log 7. I didn't change anything on the right side. So what I did here on the left side is I factorize this x here and here. That's just a factorization of common terms. Okay, and now the last step to leave my x alone is move all this big term to the right side. And because it is multiplying on the left side, when I move it to the right side, it's going to be dividing. So I'm going to have something like x equals minus 4 logarithm by 7 over this whole big term, which is minus log 7 minus 3 log 16. And that is the answer to this exercise. In this exercise, in the title, you see exact answers, which means you don't have to do this in your calculators, which means you just write that down into Alex. And if I click here in Alex solve, there you see I have the same answer, minus 4 log 7 over minus log 7 minus 3 log 16, which is exactly what I got here. Let us check. Of course it's correct. Let's try to do another one because this was a little bit harder. But remember that at the beginning I told you there were two possibilities, using natural logarithms or logarithm base 10. So for this exercise in particular, let us use the natural logarithm form. Okay, let's do that here. So it's the same. I have an equation with the x in the exponent. So I have 9 to the minus x minus 4 equals 4 to the minus 5x. And in this exercise, you will always realize that the x is in both exponents. So what I want to do here is apply a logarithm. So I want to apply a natural logarithm to both sides of my equality. So if I apply a natural logarithm here on the left side, I have natural logarithm of 9 to the minus x minus 4. And on the right side, I have a natural logarithm of 4 to the minus 5x. All I did here was apply a natural logarithm on both sides. And I could have just applied a logarithm base 10, but for this exercise, let us do a natural logarithm. I did that because I want to apply the power rule, which is what I'm going to do now. Remember, power rule tells me when you have an exponent in your logarithm, you can put it out of there, like this. That minus x plus 4 minus 4 will go down to this place. So I'm going to have minus x minus 4 multiplying my natural logarithm of 9. And I no longer have anything here because I put it down, just like that. Okay. And that is equal to the same. I will take this number down to this side because of the power rule. That is the power rule. So I will end up with minus 5x. Let me just move this a little here. Okay. I will end up with natural logarithm of 4. All I did here was apply the power rule of logarithms to take the exponent down. And here, what I want to do is take the terms that have an x to the left side or to the right side. It's the same. In this case, I see that I have an x here and I have an x here. But before that, I want to do this multiplication. So let's do that multiplication first. That is minus x times natural logarithm of 9, this by this, then this by this, minus 4 natural logarithm of 9, just like that, equals minus 5x natural logarithm of 4. And yeah, now that I have distributed the multiplication, I can choose anything that has an x to the left side and anything without an x to the other side. So I'm gonna leave this term here because it has an x. I'm gonna leave this here for the moment, and I'm gonna move this to the left side as an addition. 5x natural logarithm of 4 equals 0. Now there is one term that does not have an x here. This term should not be here because it doesn't have an x. I'm gonna move it to the right side. And if I move it to the right side, it's gonna move adding up because here I have it subtracting. So we're gonna have minus x. Oops, no. Again. We're gonna have minus x natural logarithm of 9 plus 5x natural logarithm of 4. Okay, that is equal to 4 times the natural logarithm of 9. And all I did here was take this term to the right side. Now that I have all of the terms with an x on the left side, I can factorize. I can factorize the x because the x is present in both terms, and I do this factorization the following way. X, that is multiplying, minus natural logarithm of 9. That is also multiplying 5 times the natural logarithm of 4. And that is equal to 4 times the natural logarithm of 9. I didn't move anything here. And finally, I have a big number here that is not leaving my x alone, so I gotta move it from there. And because it is multiplying here, I will take it to the other side by dividing. I'm gonna take it to the other side by dividing. So let's copy that. And I'm gonna have this x equals 4 times the natural logarithm of 9 over this big number that I just copied here, and that should be the answer to this exercise actually. This big number. Let's see this Alex option. Oh, okay, here. So if I click solve, yeah, pretty much the same number. I have 4 times. I have 4 times the natural logarithm of 9 minus 9 times the natural logarithm plus 5 times the natural logarithm. And you see that here Alex writes the answer as a log base 10, and I wrote it here as a natural logarithm. It's for Alex in this exercise, you can write it either way, and it will be correct. So check, and there it is, correct.